Hello everyone, this is, um, there we go, Math 2ZZ3, and this is assignment 1. So we'll be going through my questions, and yeah, let's get straight to it. We got a long assignment ahead of us. So this first question, if we recognize that f at x is on a total interval of -1 to 1, both of these being exclusive, um, then we could call this a Fourier series on a symmetric interval, in which case we have corresponding formulas to help us solve for, ABC. Now, they're saying our solution is of the form, CO, and they're telling us to solve for CO, and so, just looking at it, CO equals A0 over 2. So, yeah, so you're gonna have to find like A0 as you always do, um, and then just divide it by 2. Like it's not we always do that, but I mean they just want it like that now. So if we go about my question, uh, sorry, I'm a little bit tired. It's like 1 o'clock in the morning, but yeah, if we go about this, C0 equals, we don't know that, and then we know that A0 though equals 1 over P, from the integral of -P to P for f at x dx. And in this case, when we split up our interval from we'll split it up from -1 to 0 and then 0 to 1, then what we will get is the integral, and I'm going to skip some steps just like because I think that they're easier to do. Sorry, this is 0 to 1 then, 3x dx, right? Because we're just subbing in the values that we got right here. All right. Then we're going to get, 6x evaluated from 0, -1, plus 3x squared over 2 evaluated from 1 to 0. And then this, after you expand everything out, you'll get 15 over 2. And of course, this is not correct yet because we have not divided by 2. So this is A naught, and then our C naught equals A naught over 2 equals 15 over 2 times 2 equals 15 over 4. And that is A. Okay. And let me add a few pages, because I'm pretty sure this is pretty long. Okay. So B is asking us G1, which is AN times cos n pi over P x. We know that P in our scenario, P equals 1, right? So that makes our life a lot easier. That's also part of the reason why I didn't write anything here, because I just know it's 1. Okay, so I have these pre-solved because I don't like to write down in my notebook and on my iPad for my homework, so I just I do it on the side. Okay, cool. By the way, I'd highly suggest printing the formula sheet out and just keeping it next to you. I personally like to print stuff out, but yeah. So this is gonna be a little bit longer. Let me find a nice color, man. I don't know if I got any nice colors here. Let's go. I really want to get maroon, but I don't know. Guys. Let's just go with this looks kind of sick. I don't like it too much. Okay, maybe this. All right, that's a little bit better. Okay, so then what we're gonna do is I have to hurry this up because I'm at 16% already. Damn. So we have to calculate G1 at nx, and we need AN for that. 1 over P, the integral -P to P, f at x times cos n pi x over P dx. Cool. So expand it out. We're going to take this in 2 parts, okay? So the same way as we did it before, I'm just going to evaluate the first one from -1 to 0, 6 cos n pi x, because the p is 1. And this equals, after you evaluate it, 6 over n pi sine. It's negative n pi, but like we don't really care about that because you're just shifting it over, right? So this is really just n pi, right? And we know that this is eventually going to be 0, but yeah. And now our second part is 0 to 1 for 3x cos n pi x. And this is where u equals 3x du, because we're going to have to do this integration by parts. You could take this on the outside, but it doesn't really matter. This is just going to be 3, and then our v and dv equals cos n pi x, and this will, of course, equal sine n pi x over n pi, right? Okay, cool. So I don't like, let me read through this a little bit. Okay, like I could expand out the whole thing, but like you're gonna do integration by parts, and I feel like you guys could do that. So I'm gonna write down this step, and if you want, you could really just like integrate calculator. That's gonna be something we're gonna use a lot, is integrate calculator throughout like these videos, because doing the actual like, you know, mechanics by hand is gonna be, it's gonna take much longer than it's actually like valuable to you guys. So I'm gonna write down, you know, the next most important step, and I think if you enter this in Child's Math, it'll still give it to you right, but just in case, you know, for test sakes, damn, my thing's like burning through battery right now. Just for like test case scenario, just know that like, you know, these sine pi's right here are going to be equal 0, okay? Sorry, this is cos and pi. There you go. So you really just have, you know, this portion right here, and that's all you need. So when I put this in, it's 3 cos n pi over n squared pi squared minus 3 n squared pi squared. Okay, cool. If we go down to C, this thing's freaking burning the battery. I hope that doesn't bring down the brightness for you guys. I don't know if it does, but like, we'll see in a second. So then I gotta solve for b for c of 1 over p. Go negative p to p. P for fx sine n pi x over p dx. So I'm going to have the same thing in the sense where, like, I'm going to expand this out, like 0 to 1, 6n pi x dx plus 0 to 1 of 3x sine n pi x dx. Okay, cool. And so our first one, let's call this 1 and 2. Our first integral will evaluate after, you know, everything, negative 6 n pi plus 6 cos n pi over n pi. Literally don't worry about the negatives in the bracket. It really doesn't make, like, it really doesn't matter. And our second one will be, we're going to have to do integration by parts once again. Equals 3 v and dv. This equals sine n pi x. And this is equals negative cos n pi x over n pi. Okay, cool. So you do a whole bunch of more work, and you're going to get down to negative 6 over n pi plus 6 cos n pi over n pi. And then you're going to get, oh damn, my battery pencil's low too. Then you're going to get, yeah, so you're going to get plus 3 sine n pi over n squared pi squared minus 3 cos n pi over n pi. And this goes away, and what you're left with will be the answer. I'm going to stop right here and then cut back to when these things are charged up fully. Hello everyone, just gonna check that I'm recording with the audio real quick. All right, sick. So we're gonna continue off from where I left off in the last kind of little bit. with assignment number 1. I'm recording this way later than it should be, but you know, shit happens. So from where we left off, we just kind of written out what Bn was, and to get it in the form of g2 and x, we're just going to continue negative 6 over n pi plus 6 cos n pi over n pi minus 3 cos n pi over n pi times sine pi n, and the p in this case is 1. Yeah, it's just 1. So n pi x. Oops. Where'd I go? N pi x. And that is the answer for C. So if we go on to 2, we need to find the value of CO. See if I could get like a smaller. That's fine. I just need a nice color, man. I got no nice colors here. Fuck it. I don't know. Let's go orange. Actually, I don't like that. Let's go red. Oh, nicer. All right. So find CO. Okay, and we have f at x. Honestly, I gotta go back into my solution notes because from what I remember, this question was on the longer side, if I'm not mistaken. One second, people. All right, I have it in a different book. I'm so cooked for today because I have to finish the MATLAB and then get that out to you guys. And then by get that out to you guys, I mean I have to help people solve MATLAB, troubleshoot, like solve them, help their questions. But yeah, other than that, I am absolutely not aiding in any way. Just so I don't get a TA on my ass again. Anyways, so let's find CO. So we want A naught, and this is going to be 1 over, let's close this. Holy fuck. Okay, A naught, in this case, we're going from negative pi to pi. And so our P equals pi. I'm never doing the small font again. It looks like ass. And then we're going to integrate from negative pi to pi for 6. And we can also do that for negative pi to pi for 8x dx. All right. And so if you compute this, you're going to get 12 pi over pi. You'll realize that cancels out. This is A naught, but because C naught equals A naught over 2, then we want 12 over 2, which equals 6. All right. If we then go on to find AN for B, you'll realize a lot of these questions are similar format. We're going to have 1 over pi from negative pi to pi for 6 minus 8x cos nx dx. I honestly let me see what questions don't rely on just pure integration, because I honestly think you guys can do the integration. I just want to write down the final steps for some of these questions, because other than that, it's really just you got to make sure your integration game is good. And if you're in Calc 4, I'd really fucking hope so. Okay, so in this case, it's it's cos n pi x over p, and so it's it was really this, right? But that was canceled out. So you're just going to compute this integral, and yeah, and then after you compute that, you will realize that you're going to have everything cancel out. So it'll just equal 0. Why does it cancel out? Good question. Let's go into a little bit more depth on that. So you're going to have 6 over pi. This question, I'll do it. 6 and pi over pi, over n minus sine n pi. It's a negative here, but it doesn't matter. You know that. You'll know this goes to 0. Okay? And you can have minus 8 over pi of pi sine pi n over n. We already know this goes to 0. Plus cos n pi over n squared plus pi sine n pi over n goes to 0 as well, minus cos n pi over n squared. 0. And so that's why this all equals 0. Okay. Let's add a page. Maybe even another one, just to be on the safe side. Okay. So then we go to Bn is going to equal 1 over pi, the integral of negative pi to pi of 6 minus 8x sine n pi x over pi dx. Compute this integral, and you will get, make sure that, yeah, that's about it. Okay, after you compute this integral, you're going to get 6 over pi n negative cos pi n. Sorry, so also go away. You're going to have pi x. Yeah, no. Hold on. Wait a second. 6 nx. Yeah. Okay. Cos pi x plus, because this is after you evaluated everything. Like you evaluated the integral, the definite integral. You'll see that these two disappear, and this whole term goes to 0. And then you're left with negative 8 over pi, negative pi cos n pi over n plus sine n pi over n squared minus pi cos n pi over n minus sine n pi over n squared. Okay, so these two will go away, as we know. You're going to get negative 2 pi, and so when you evaluate everything out, you're going to get 16 pi over pi cos n pi over n. That's going to cancel out, and then you're just going to have 16 cos n pi over n times sine n x, because the pi's will cancel out. And that's number dos. Moving on to number 3. Understand that for this, you are going from negative 4 to 4. P equals 4. Your CO is just going to be A naught equals 1 over P, as always, from negative P to P, fx dx. Okay, cool. This is still just a cos, like you're expanding the cosine series. But if we look at our formula sheet, yeah, it's just a regular cosine series. You're not doing half range or anything like that yet, so don't worry about that. I find it odd though that they don't have like the 0. Yeah, they don't have the 0 to pi integrals, which is a little bit weird, but we'll see what we have to memorize later on throughout this assignment. So what we'll get here is we're going to have to evaluate everything like and break it up. So like I'm even looking at like this solution in front of me, and I'm realizing like the solution in front of me is completely wrong. I was looking at the wrong page because I'm looking at, like, I know I have a piecewise function, so I'm forced to break it up regardless. So what I'm going to have here is 1 over 4, the integral of negative 4 to 4 for f at x dx. But in order to do that, I have to have 1 over 4. Then I have to go negative 4 to 1. So the integral from negative 4 to negative 1, for 8 dx. I'm going to have to add that from negative 1 to, 1, for 7, and then goes back to 8, 7 dx, plus 1 to 4, 8 dx. Evaluate all of this, and you will get 31, yeah, you're going to get 31 over 2 for A naught, and as always, C naught equals A naught over 2, and you're going to get 31 over 4, right? Okay, so I guess this one's probably the one where I have to have 2 pages. So then, we're going to look for G1 and X, which G1 and X is always the one where you multiply by cos. And so I'm looking for AN, right? And AN in this scenario is going to be 1 over P, the integral of negative P to P for f at x dx. And then times cos n pi x over 4, of course. So if I just get rid of these, just so I don't have to rewrite it all over again, 4, 4, 4. And you're going to take this exact same integral, okay, and then multiply down here. And you're, of course, going to expand the cosine into each and every one of these. So after you evaluate that, you're going to get AN equals negative 2 sine pi n over 4 times cos n pi x over 4 over n pi, and this is correct. I really, like, this video will be ages if I go through each and every integral. And you're not evaluating for Bn because you are not asked to. So then they asked us to find the half-range sine expansion of the function from 0 to 5. So if we look at our formula sheet, we're asked for, so the half-range ones are the ones that are going from 0 to L. They just don't give us the integrals for it. Okay, cool. That is perfectly fine. Sorry. It's actually, I don't know why I'm so tired today. Okay. So if we go to set up our integral, we're looking for sine, which is going to be f at x equals the sum from Bn sine n pi x over L, where L equals 5, okay? And so then we're going to do we have 2x, so we're going from 2 over L, the integral 0 to L fx sine n pi x over L dx. We sub in our function, and we're going to get 4 over 5, the integral 0 to 5, x sine n pi x over 5 plus 4 over 5, what is that? Oh, sorry, this one's going to be 8. This one's going to be 2 times 8, so 16 over 5, the integral 0 to 5 of sine n, I'm writing that wrong, sine n pi x over 5 dx. And you're just going to evaluate this, and after it's evaluated, you're going to get negative 36 cos pi n over n pi minus 16 over n pi, and now, of course, you have to multiply this by sine n pi x over 5, which is L. And that is correct. Oh, hold on. Add a positive there. Well, it becomes positive after you expand it out properly, which is something that I initially didn't do. Sorry about that. Okay, so let's move on to question number 5. This one has 8 questions, so it makes my life a little bit easier, which we're always here for. Okay, this is, we already did a question similar to this, so I'm going to set you guys up with the integral and steps, as always. C naught equals A naught over 2, and because we're asked to expand this following function into a Fourier series, and we're given it from 0 to 7. So we don't have a even interval like this. We don't have this. We're going from 0 to 7, or more commonly, we can refer to this as 0 to L, which we can, assume at that point that we're going to do this as a half range. The question is, what half range are we doing this as? Well, okay, we already know that there's, okay, so like they're telling us G1 to find G1 at X. This is an even function, okay? And then G2 at X is to the power of 1. So this is G2, which is odd. So the first one's evaluated as cos, the second one's going to be evaluated as sine. But A naught stays the same. And so to solve for A naught, we're going to 2 over L, which is 7. The integral 0 to 7 for 8x squared plus 6x. And then A naught will be 9/10 over 3 times 2. And so this equals C naught now equals 455 over 3. C naught because I multiplied by 2. Now, for AN, we're going to get 2 over 7, the integral 0 to 7 of 8x squared plus 6x times cos. And remember, for these sine, for these like half-range expansions, you also have the 2 being distributed inside. So 2 pi nx over 7. Okay. I just want to make sure that I'm not messing that up real quick. Well, we're going to search up half-range sine expansion. Half-range cosine expansion. Because I don't know if my handwriting is messing me up or I'm messing me up. One second, guys. Go back here. Oh yeah, that's right. Because it's 2, and then you have L in the denominator. Okay. And then you're going to expand this out after you've evaluated it with that cos. And once you do that, you're going to get 413 n squared pi squared cos 2 pi n minus 21 over n squared pi squared times cos 2 pi n x over 7 in the cosine function. If I add a page here, so we can do Bn. Bn will equal the integral from 2 over L, which is 7, 0 to 7, 8x squared plus 6x sine 2n pi x over 7. And we're going to get, let me write down the previous step just so I can cancel something out. 413 pi n sine 2 pi n over n cubed pi cubed plus 190, oh, that's a big term, I gotta write smaller. 196 minus 434 n squared pi squared cos 2 pi n over n cubed pi cubed minus 196 over n cubed pi cubed. We know this is going to go to 0, and so finally we are left with this term. So okay, we can paste as an image. and this term. And this whole, all of these terms will be multiplied by sine 2 pi nx over 7. There we go. Now, moving on to 6. I saw a couple of people had some problems with this. Pretty sure I wrote out full solutions for these later on in my notes. So give me just a moment to find them. So I write a lot in these notebooks. Oh, yeah, I had 4 even written out fully too. All right, guys. So I got to timestamp all of these, damn it. So, for question number 6, scroll back up a little bit. We're given we're given f at t. Oh, what am I writing? There we go. So for question number 6, we're given f at t as a piecewise function. And we're told to assume that if it's extended on the negative on the negative t-axis, which is, just the x-axis to the left, the resulting function is even. So if we extend it to the left, it's still even. And that's really what we're looking for. We're looking to evaluate this in such a way that we could use like a half range, because like this is half range, 0 to 2 pi, right? So our L equals 2 pi. So we're looking to evaluate this in a way that we could use either sine or cosine, and they're telling us if we extend it to the left, then it's even, which means we're going to be using our nifty cosine function. Now, we're going to find our a naught first, which would be 2 over 2 pi, the integral from 0 to 2 pi, subbing in everything. We're going to, so actually before then, f at t dt, because it's piecewise, we're going to split it up. So we know that we're going to have 1 over pi, the integral from 0 to pi for 5, minus the integral from pi to 2 pi for 5 again. And the negative, I just brought it on the outside. Awesome. So after we evaluate this, we're going to get 0, no matter what. This is 0. This is not the first question I've done, and it's 0 for almost every single one of these questions. Now, given that, we're going to continue to solve for an, because that's the one that's given in our particular solution. Even if you didn't know which function you had to use, it was probably in here. Okay, so I'm going to get to the differential equation and how we're going to use the sum in a second to solve really for an. We're solving for an in this case because always our functions are in gnx times cos n pi pt. Like this is what we're always looking for. So an is our gnx, and so we need to solve for an, not the big an, the small an, in order to solve for gnx. Okay, so then we're going to do 1 over pi, the integral 0 to pi for 5 cos n pi t over 2 pi, right? And we're doing n pi t because it's this right here. We're not evaluating this with cosine anymore. But I'm going to double check that because even as I say it, it seems a little weird. So I want to make sure I'm not saying anything wrong. Okay, so I come back down to number 6. Yeah, so we're using just n pi t. It's going to cancel out, subtract from pi to 2 pi for 5 cos n t over 2, because that's really all it is. Awesome. So after evaluating this, we're going to get 20 over n pi sine n pi over 2, which is awesome. So we now have an, okay? And our f at t equals the sum of n equals 1 for our an, which is 20 over n pi times sine n pi over 2 times cos nt over 2, right? Awesome. And this is because this was previous n pi t over 2 pi, but the pi's cancels out. So we know that this is, it's our an, okay? And in this case, we now also have our particular solution. Because if our particular solution is in the same format, an cos n pi t over p, right? Then this an must be here, giving up that kind of bracketed term. So what you're going to do is you're going to take, now you're going to use the, like our differential equation of d2x over dt squared plus 7x equals f at t. So we can plug in f at t fully because we now have it, right? And you're going to take the double derivative. So I use software to take the double derivative because, I mean, if it really comes down to it, we know how to, but we don't really need to. And so what we get, in a very long-winded way, is, and I'm gonna let you guys, I'm gonna let you guys expand everything out if you want to, but I personally did not. So what we have is -4. Yeah, let me bring it down to this. So if x at p xpt equals this Riemann sum, or this sum of an cos n pi over pt, and we plugged in this, so I could really just simplify this to n t over 2. Then if we take the double derivative, xp double prime t, we're going to get -4 an times n squared over 4 cos nt over 2. And then the other one's just going to be plus 7 an. We're going to sub in an a second, guys, but don't worry about that. Cos nt over 2. And remember, this equals f at t, which is the sum. Let me not forget the sum symbol here. 1 second. This is also the sum of n equals 1. You'll see why I wrote that down in a second again. And this is 20 over n pi sine n pi over 2 cos nt over 2. Okay. So we're looking to solve for an because we don't have gtn, but we're looking to solve for an. All right. So what we could do here is we could factor out the sum terms and cancel them. So that's what we're going to do. So if we factor them out on both sides and cancel them, just imagine this goes away and you just have this, right? And then you just cancel both of them. -4. Hey, to be honest, when I saw this happen, when I asked a friend how the fuck he solved this question, I was just absolutely blown. But we're gonna go with it, to be honest. Equals 20 over n pi sine n pi over 2 cos nt over 2. You also see we have another thing we could factor out, another portion, which is the cos nt over 2. So that can go away. Now we'll have negative 4 an times n squared over 4 plus 7 an equals this. Okay. And then solving for an, we get 20 over n pi times sine n pi over 2 times 1 over 7 minus n squared. And when you plug in your answer, just multiply this by cos over nt over 2. If I look back at this question, I think it's quite misleading when you get to here. I don't know why. I don't know. I think I would just try and assume that like that's the an that I'm looking for. But at the same time, you wouldn't have used the other portions in this. So I guess you have to solve for an to get f at t, and then take the double derivative to use the actual equation. That's the best way I would put it. All right, so on to 7. We have 2 more questions, guys, so bear with me. Well, just this and one more. Okay, so first we're going to solve for C0. We are back to having an even interval. So we know that our p equals 4. Now the only thing is though, is that we're asked to find the complex Fourier series. So we have f at x equals the sum from n equals, if I look at my formula sheet, for complex Fourier series, we're going to go from negative infinity now. Negative infinity for Cn e to the n pi x over p. Now, if I want just C0, right, then what I can do is just using C0 equals 1 over 2p, integral negative p to p, f at x, and then the other e portion just goes away. You don't have to worry about that. Let me make sure of something. Yeah, because if I'm let me just go about doing it again. So f at x dx. So we're gonna have 1 over 8, negative 4 to 4, 4, 10, plus negative 4 to 4, 4, 7x. So here you're gonna get 10x. Evaluated at 4 to negative 4, plus 7x squared over 2, 4, negative 4. Okay. So then we're going to have 40. Yeah, so 40 minus 40, this thing's going to go away. Oh no, 40 plus 40, we're going to have 80. Got to be careful with those. And then we're going to have, so we're going to have 16 times 7 divided by 2, 56 times 2 plus 112 over 8. So we're going to have 80 plus 112 divided by 8 equals 24. Unless I did that wrong. Unless I did that absolutely, utterly wrong. 1 second. Because I don't think this is where I actually solved 7. This is the problem with trying to go through these videos when like I don't do the, like most of the time I do the assignments and then the videos like immediately after. But this week's been absolutely like cooked. So now I'm like doing the assignments, just barely catching up to doing them, and then getting busy, and then having to go back and review the material. It's probably more beneficial for me than some of the viewers, but I did you guys really, I treated you guys really well in Calc 3, so now you gotta let me slide a little bit with some of these videos. Okay. Damn, it's almost like I didn't even fucking do this question. I must have done it somewhere. Because I'm not finding this in one of my in my original notes. I'm not finding this. So uno momento. Yeah. 7 I'm not finding at all, guys. I don't know why. But all right. So find a complex series. So if I look at my formula sheet, and I'm just going to try and solve this off the rip and see if I can end up doing this. But we should be fine. Okay. So complex Fourier series, I'm looking for C at 0. And so I really am just taking this at f at x. So I have 1 over 8. And then I'm going to have 10 times 4, so 40 plus 40, 80. And then we're going to have, I think I forgot the 7 over 2. So we're going to have 16. Oh, there it is. There it is. Yeah. This part will be 0 because it's squared. And so this is not 24. This is just 10. Awesome. Now, in the second one, I'm going to set up the integral for you guys, and Godspeed. So we're looking for, not b, well b, yeah, but we're looking for Cn, where n does not equal 0, and it has to be fully simplified. And so you guys can compute the integral of -4 to 4 for 10 plus 7x times e to the negative n px over 4. And good fucking luck. Now, moving on to 8. Yeah, 7, that second integral I'm not doing right now. 8 was one of the weirder questions. I have a feeling this is also going to come on the test. But yeah, let's see how we could piece this together. So we're given f1 and f2, and we're told to find a value of the constant c such that f1 and f2 are orthogonal. Okay. Do we have any formulas on our formula sheet that help us with this? Not really. But what we're looking to do is compute the inner product. From what I remember, if you multiply, if you take the integral on some interval of f1 times 6 minus 3cx, 3cx, okay, and this equals 0, then they are orthogonal. So if we go about doing that, we're going to get 0 to 1 of 6x minus 6x cubed. And then this will get us 3x squared minus cx cubed evaluated at 1, 0. And this will be 3 minus c equals 0, and so c equals 3. And then the norm of f2 on the interval will be the norm of f2x on the interval. And so we're looking to do 0 to 1 of f2x squared, of course, dx. And so if f2 at x equals 6 minus 9x, then f2 squared equals 36, double the product of the two, minus 108 plus 81x squared. Computing the integral of this now, and we'll get 36x minus 54. Sorry, this is 108x. 54x squared plus 27x cubed. Evaluated from 1 to 0, and we will get 9, and so root 9 equals 3, and this is B. Awesome. Thank you guys for tuning in for the first video. I apologize for recording this a little bit late, but it's up now.